Question 7. We have a diagram here that shows a parallelogram, ABCD, and shows an isosceles triangle, DEF, as follows. We are given the angle 58 degrees here, and the question is asking us to calculate the size of angle DEF, which is marked on the diagram like so. The question also stipulates that you give a reason for each stage of your working. Now, this question is worth 5 marks. 3 of those marks is got from doing all the calculations, the number part. The other 2 marks comes from a full breakdown of every reason why you used the angle rules that you did. Now, there's a few ways in which you can get the following angle here, CDA. The way I'm going to show here is what I would refer to as the easiest, and then from there, all of the reasons need to match what I'm doing here in terms of the steps that we take. So, given that we have a parallelogram, these 2 sides being parallel, co-interior angles, when you have a C, co-interior angles add up to 180. Therefore, I can do 180 minus 58 to get me 122. So the reason why I'm using that rule is co-interior angles add up to 180. You can't just write co-interior angles. You've got to make the statement about what about co-interior angles. So co-interior angles add up to 180. You've got the option of extending these lines and doing something involving alternate and corresponding and angles in a straight line. Like, there's more than one way of doing it, but if you want it in one step, co-interior angles add up to 180. That gets you this angle here. The next step comes with getting this angle here, EDF, which equals 122. So we could write here EDF, angle EDF equals 122, or we could just write 122 in the diagram. That's also fine, but you've got to give a reason for that. Vertically opposite angles are equal. Now, if you forget the word vertically, it's okay, as long as you have the mention of opposite angles being equal. I lost my train of thought there. Are equal. Vertically opposite angles are equal. Yeah, opposite angles and equal are the key words for the mark scheme, but vertically opposite is the technicality behind it. Now you have a triangle, DEF. If we take this 122 away from that 180, we can use that because of the fact that angles in a triangle add up to 180. So that would be our reason for doing this. Angles in a triangle add up to 180. Now I know we're back where we started in terms of the 180, but you're not expected to know that this here would be the same as the size of those 2 angles added together. So it's just a coincidence really in this question that we end up back where we started. So 3 sums so far, 3 reasons. Last but not least, this angle here and this angle here are the same because base angles in an isosceles triangle are equal. So in other words, having 58, you need to explain why you're doing that. And the reason is base angles in an isosceles triangle are equal. And from there, we have our answer of 29, along with our 4 reasons, which there should be at least 4 reasons. That shouldn't be a percent, that should be a degrees, to get our final answer, get the full marks. Done.